Hello everyone. In this video, we would discuss some concepts of pro-stereoisomerism, especially in Gujarat University. The first paper 307, the first unit is consisting this topic. It is about stereochemistry. And in most of the university, these topics are common. Maybe the paper numbers or semester numbers could be different, but these are the very basic concepts and very important for those students who want to pursue post graduation. So we will discuss in this video these three terms: homotopic, enantiotopic and diastereotopic atoms or groups. So let us start with the homotopic atoms. This word is combination of two words, homos and topes. The meaning of homos is same and topes means place. So that's why they are called homotopic atoms. Let us first try to understand them with the example. Here is in front of you example of acetic acid. This is carbon COOH axis and these are the three hydrogens of methyl groups. Now whenever we give rotation about C3 axis on this axis or at 120-degree rotation, so the position of these hydrogens, three hydrogens of methyl group, can be interchanged and we are getting indistinguishable structure. So we can say that these three hydrogens of methyl groups of acetic acid can be interchanged by CN operation. In this particular case, it is a C3 operation. So if we read the definition, homotopic atoms in a molecule are those whose positions can be interchanged by rotation about proper axes of symmetry. So such group or atoms, they are called homotopic groups or homotopic atoms. Three hydrogens of acetic acid are homotopic atoms. Now let us discuss enantiotopic atoms. So first, let us try to understand the example. Here you can see that this is ethanol molecule. Two of its hydrogens, one by one, when they displaced by some common group. So here in this example, I have replaced them by chlorine. So you can see that in the right side, this hydrogen is displaced by chlorine. We are getting this isomer. And when the left one is replaced, we are getting this one. Now these resultant isomers, they are asymmetric as well as they are enantiomers of each other, as they have mirror image like structures. Moreover, they are not superimposable over each other. So these original groups, which themselves are not asymmetric or chiral, but their replacement by some common group give rise enantiomers. In such case, these two hydrogens, they are called enantiotopic protons, we can call them, or they are called enantiotopic atoms. One more definition of enantiomers symmetry point of view is these atoms are interchanged or can be interchanged by SN operation, that is rotation reflection operation. So these are the two definitions of enantiotopic atoms or groups. A pair of atoms in a molecule are called enantiotopic when they are interchangeable by rotation reflection, that is SN operation. And as I have mentioned, substitution of these atoms by similar group or atom gives the corresponding enantiomers. Now let us discuss diastereotopic atoms. Diastereotopic atoms of the molecule are those when their replacement by some common group or atoms give rise pair of diastereomers. So you can see that here this structure is chloroethene or it is also called vinyl chloride. Now the two protons of vinyl group A and B, one by one when we displace them by some common group, see if this one is replaced by chlorine, A, we are getting this structure. And when B hydrogen replaced by chlorine, we are getting this structure. If you carefully observe these two resultant isomers, they are not enantiomers as their structures are not mirror images of each other. They are also not superimposable over each other. That's why we can say that they are diastereomers of each other. So originally these two hydrogens, their replacement give rise diastereomers by some common group. That's why they are called diastereotopic protons. One more example would make it more clear. Here you can see that here these two hydrogens, if one time we replace this by bromo, we are getting this structure. See, two hydrogens are at a erythro position or at the same side. When this one is displaced by bromo group, we are getting the isomer in which chloro and bromo are relatively at a trans. Now, see this one and this resultant isomers, because of this HCCl group, they are not mirror images, but they are, as well as they are not superimposable, so they are diastereomers of each other. So, such atoms whose displacement give rise diastereomers are called diastereotopic protons. And symmetry point of view, we can say that such atoms or groups cannot be interchanged by any symmetry operation, whether it is a Cn or I or Sn. So, homotopic, enantiotopic, and diastereotopic, if somebody asks you how one can distinguish whether the atoms are homo, enantiotopic, or diastereotopic, answer is that if the atoms or groups are interchanged by Cn operation, they are homotopic. If they are interchanged by Sn operation, they are enantiotopic. And if they are not interchanged by any symmetry operation, then they are called diastereotopic atoms.